Okay, today I'm going to go through use case diagrams, and hopefully either Ashley or Sherwin is actually playing this video and we're all right to go, and hopefully the data projector is working properly and we're right to go, and hopefully no one's got their caps on, not looking at anyone in particular. We're all ready to learn and we're all ready to listen. And the first thing I'd like you to do is open OneNote. I should say open your OneNote, so just open OneNote. And I want a new heading, and I want your new heading to sort of say use case diagrams. Now what I'll do is I'll actually play this and have it full screen, so hopefully you can see it. So open OneNote, new heading should say use case diagrams. Take notes when prompted, and the PowerPoint will be available on the blog, and I'll get Ashley or I'll get Sherwin to actually stop the video so you can take notes as we're going along. So just make sure OneNote is open, new heading, use case diagrams. Alright, so I'll get them to pause, make sure everyone's doing that, and when you're ready to go, we'll start again. Okay, here it is. Here is the start of the PowerPoint. Now we'll be looking at UML. So UML stands for Unified Modelling Language. It is a language that we're going to use to create a lot of diagrams that we'll be using in software development. Now this PowerPoint was developed by Miss Dennis in 2015. She's a wonderful teacher. She teaches at Strathmore Secondary College. Alright, now here is a picture of a use case diagram. So you can see here that we have actors. There's a skinny stick people here. We have use cases which are shown by an ellipse. We have the system, which is this rectangular box, and we have relationships, which are the lines. Shows you a relationship between the actor and the use case. So that is the big picture view of what a use case diagram will actually look like. You will all create use case diagrams in this outcome, in this SAT. Alright, now here's where I want you to take notes. So the first subheading is Unified Modelling Language. I'll just read the slide, and I'm going to get you to copy out the second, at least a sentence from the second paragraph. So, Unified Modelling Language, a tool and technique for depicting interfaces between solutions, users and the network. The Unified Modelling Language is a standardized modelling language that encompasses a large variety of different diagram types that can be used to represent many aspects of software development. So what we'll get you to do is we'll pause the video here, and I want you to take notes. You don't necessarily have to write all this down, but at least take some notes here so you understand what Unified Modelling Language actually is. Alright, now we're ready to go and continue. Now what does a use case diagrams do? Miss Dennis says it tells a story of how the functions within a system work. So the story is what is actually going on. Now I've highlighted in bold here, should show non-technical people what the system should do when it is completed. So this is a really crucial point. So it shows people who aren't software developers what's going on. Should show developers exactly what is expected, so it's handy for them as well. Now another crucial point is, does not go into detail of how a system will do something. So just what that will do, not how it will do it. Okay? Occurs in the analysis phase of the problem solving methodology. So you will actually put this in the analysis phase, which is your systems requirement specification. Alright, so you might want to take some notes of this one as well. The key points are what I've put in bold. Okay, let's move on when you're ready. Alright, use case diagrams. 3 components. It has actors, use cases, and it has a system boundary. The actor. An actor is a term used to represent a role that is external to the system. This is a crucial point, external to the system. It is often a person or an organisation. But don't use real names. So we don't say Harry, alright? We generalise the term, e.g. staff, teacher, manager. I'd also say it represents a customer, an administrator. So you just use a generalised term. Stick figures are used for actors, you'll see that. Actors connect to use cases. So there's going to be a line to show you the relationship between an actor and a use case. Actors should always be nouns, okay? So we're talking about proper nouns. Alright, use cases. So a use case represents a function within the system. A use case is shown as an ellipse with a function written inside of it. The use case diagrams are often the first tool that is used in coming to an understanding of how a system works. Each use case is often quite broad. Use cases should always be verb phrases. So e.g. delete account. You could also say take order, place order, submit details. So we're looking at a verb phrase. Very important to do this as well. System boundaries. A system boundary is a rectangle that is drawn around all of the case symbols and represents the bounds of the system. Now the actors are outside of the boundary. That's a crucial thing. The actors are outside of the boundaries. Although there will typically be only one system boundary, it is possible to have subsystems represented by additional system boundaries inside each other. So the crucial point here is that you need a system boundary that is drawn around all the use cases, and actors are outside the system boundary. Now this will make a bit more sense when we get to some diagrams up ahead. Relationships. So this is quite a very important point, so I want you to take some notes here. Relationships, so the new subheading. So solid lines represent relationships. Okay, relationships can exist between actors and the use case, an actor and another actor, use case and a use case. And there's 4 types of relationships: association, generalisation, really important you understand this, include and extend. Now the rest of the video is going to go on terms of this one. So this is an example of an association. Association between actors and use cases. So here is our actor, in this case teacher. Now here is a system to view your grade. Now we have a system here, you know what it is, it's Compass. You can view your grades, I can view your grades. Now I can submit your grades, you cannot submit your grade, but we can both view the grades as well. So illustrate as a straight line connecting an actor to a use case. Okay, so we would put a boundary around here. We might call this at the top, we might actually call this compass. So around here would be our boundary. We'd have a teacher, can view the grades. Generalizations are used to indicate inherence of an item. Shows a parent-child relationship. Now remember we talked about parent-child relationships, I'll go back one, when we talked about XML. Each child should have a slightly different purpose or functionality, often used when the same job can be performed differently by different users, shown with a straight line with an open arrow head. So here's some examples. So view grades on the system, view grades on a web page. So the thing is, view grades is the most important thing. We either have one or two ways. So here is a really good example. I can view grades internally because I'm a teacher. I would view grades in a slightly different system than you would view grades. So you can view grades on your web page. You can either view grades on a web page via your phone, or you can view grades on a web page on your home computer or a computer at the school. So there it is. So here's another one. We have a cook, we have a Chinese cook or an Italian cook. So they're generalisation examples. Now here is this diagram again. I'll just reiterate it. So here we have an association. So we have that arrow going down. We've got the developer, we have a tester. So there's a parent-child relationship. There's the parent, there's the child. We have use cases here. Right application, there is a use case. Here we have an association, the line between the developer. What can the developer do? In this situation, the developer can. Tell me what the developer can do. So I want someone to pause the video here, and I'd like you to tell me what each actor can do. Okay, so hopefully you would have said something like the developer can write an application, can compile an application, the scheduler can also compile an application, the tester, they can only do one thing. All they can do is test the application. So a tester actually might even be a student. I might create something like Compass and I get you to test the student section of it, so you would test it for me. Alright, so we have everything here. We have relationships, we have use case, and we have associations. Alright, here's where it gets a bit tricky, but hopefully we'll illustrate this with some example. So includes and extends. Dotted lines with an arrow head are either include arrows or extend arrows between use case X and use case Y. Where an arrowhead points to Y, it means that the process of doing X always involves doing Y at least once. It needs to be labelled to include. When the arrowhead points to X, it means that the process of Y may be added on top of the functionality of X, but is not always needed. It needs to be labelled extends. So include is must have, think about it like that. Has to happen in order for it to work. Extends is it doesn't always have to happen. It can actually be an optional extra. It can actually add some more functionality to what we're trying to do. Here's an example. This shows the use case record grades, and upgrade grades require the functionality to save grades. So in other words, in order to record grades, we have to save it. In order to upgrade grades, we also have to save it. Now I'm just going to exit the video because there's a rather good example of this in the on the website here I'm about to show you. So last year, this question came up. It came up about use case diagrams in the exam. Now, I'll just note before we start that this exam question was worth 4 marks. The state average of this question was 0.7. So I'm hoping that you can understand this, and if you get a higher mark than the state average, you will get a higher score. So the way you get a really good mark is you end up getting marks in the exam that other students do not get. So it's really important you can understand things like I'm about to show you. So here's an example of includes and extends. Alright, a system is a pathology system. So in other words, it's a system that has doctors and patients and pathologists. So here's what the patient's doctor can do. They can view results in the patient file. Now to do this, they have to actually log in because it says includes login. They have to do that. That's why the arrow is going this way. You have to do that. It has to include a logging in. Now, what can a patient do? They can enter and view blood levels. So obviously they're taking their blood levels at home, then they can enter and view blood levels. But they have to log in. They have to actually log in order to do that. Now, pathologists store patients' records in a patient file. They don't have to log in to do that. There's nothing here to say that they need to do that. They can just do that. They can analyse blood sugar levels, but to do that, they have to log in. Now, the extension is the pathologist can also enter and view blood sugar levels. So the pathologist can enter in a patient's level. So that's an extension. It doesn't always have to happen, but they've got that optional extra here. So that is a question in the exam. And hopefully, that's an example of how to do an extend. Alright, so I'll go back to the video now. I'll go back to the PowerPoint. And here we go. Go back to start slideshow again. Alright, so we're nearly come to the end of this. There's an example of an extend. I just showed you what an extend does. It's an optional extra. Now the advantages of the use case, they're simple, easy to read, good to use as a starting point when looking at the functional aspects of the system. Disadvantages can get quite bloated and complicated. Can still cause ambiguity. Remember, they're supposed to be a simple snapshot of the system, but sometimes they can be too simplistic. Does not represent the order in which functions are used. So it only shows you what happens. It doesn't really show you why it happens or how it happens. So it doesn't really give you a detailed picture. Does not represent the number of time functions are used. So it's just a simple first snapshot of what the system that you're designing will actually be. Alright, now the next thing I want you to do, I want you to we're going to create a use case of ordering a kebab. So I want you to actually go to the following site, and the following site is www.draw.io. Pause the video for 1 minute. In fact, I think I'm going to stop this video and I'll create a new video. But I want everyone now to go and to access this website.